Hey, what's up? Let's go. It is time. Got the screen too different today. Got some Mega Man in the background. We're ready to go. What questions are there? Hey, Sylvia. Hey, Sarah. Hey, Madeline. 50 points. Everyone showing up here to office hours. I was just showing off once again at the start of office hours. If people are watching this right now, we should be live. I think we're live. Hey, Alex, what's up? So we should have 50 points. Alex there too. If you notice here, we have the when do we use Pearson Spearman flowchart that I made. Please feel free to ask for stuff. I made this because a few people asked via email. So you guys are cracking me up in the chat. It's balloons. It's the balloons. They've deflated. The balloons. We're going to do all of office hours.
All of office hours will be done like this. What questions are there? We'll go back this way so I sound a little bit more normal. People come in. What homework question do you have, Alex? BAS 474, question 2.
I have too much fun with that stuff, guys. I have way too much fun. Okay, let's hop in here. Let's do some BAS 474, question number 2. Homework, functions, question. Did you know this? Does everyone know that this exists right here? When you're going through questions, and then we got 320 next. Let's do that. We got 474, and then we got 320. So does everyone know that this exists? That when you want to do a function, when you want to go through here, you can click, and I can go to question 2, and we're going to tell a little bit about the cosine right here. Let's go. I think we want to go one bigger. There we go. What did I do? I destroyed the chunk. This right here is when you destroy a chunk. You notice it changes colors. You don't want to do that. I think this is where we were adding stuff in. We were doing tons of stuff here, and I might have messed right here. Okay, oh, go away. Oh, what did I do? Okay, let's look at this question right here. Okay. Hey, what's up, Jordan? Hey, what's up, Anisha? So we'll go right here, and we're going to look at question 2. How did I lose question 2? Here's cosine distance. Okay, so when it comes to cosine distance, the cosine distance formula, this is BAS 474, question 2. What's up, Ahmed? Good to see you here. And so the formula is this right here. Now, this is the formula. This is how cosine distance is found. And if you look at this, it's an iterative process. Now, you would think you'd use a for loop. We've got some test vectors here. So with this, we've got 2 test vectors. And our goal is whenever we write a function, so this is 474, question 2 we're talking about right now. Whenever we write a function, we start by what? I need to hear you say in the chat, how do you start writing a function? How do you start with writing a function? What do you do when you're writing functions to write your function? What do you do to start? Skeleton, basically. Yeah, and you don't write your function. You write the inner part. You get it to work on one case. You get your function to work on one thing. You guys got it right there. So here we are. I don't like that. I like this. And if we look at this process right here, all this is the first element of this times the second element, first element x1 times first element of x2. And then you got it, Jordan. And we'll try to do all these in order right here. And then it's the second element. Does everyone see this? Like, read what this says. Let's break it apart. It is the first element of x1 times the first element of x2 plus the first element of second element of x2 times the second element of x2. Ugh, it's hard to say. Third element of x1 times the third element of x2. Does that make sense what's going on right here? You're timesing vector 1's first element with vector 2's first element. Vector 2's second element plus vector 2's second element. Vector 1's third element plus times, oh my gosh, whatever this says right here. I'm so sorry, guys. Hot lights. I've been in meetings all day, so, but that right there is vector 1's third element times vector 2's third element. Make sure you can read it just as it is. And we're adding all these together. So my goal right now when I'm doing this question is not to do the whole thing. It's just to do this. I just want to turn this into something. You got it, Ryan. We'll do question 1 here coming up. We got a lot of things on. Thank you so much, everyone, for showing up. We're going to work through cosine distance a little bit here. Then we're going to hop to 320. We're going to go back and forth between 320 and 474. So stay tuned. And this is good practice for everybody right here. Now, what we have right here is we're going to turn this into, and make sure to clean up your code afterwards, turn this into code. So we're going to turn this into code right here. So how are we going to turn this into code? I want you to take a look at this and see what the process is doing. It's just taking two vectors and doing what to them. This won't work as it is, but this is just taking two vectors and doing what to them. Taking two vectors and doing what to the two vectors. Like, what's going on with that code up there right now? It's just da-da, da-da, plus da-da, da-da, plus da-da, da-da. Yeah, definitely. We'll definitely do. Great job, Kelsey. Definitely. We'll probably be here an hour and a half, 2 hours maybe. We'll do lots of stuff. We'll do lots of practice. And then throw timestamps on the videos you want. But you're here. We're going to work on it. You're adding together this, but the first thing that's happening is this. So we're going to store these two vectors, and what you'll notice is all you're doing is x1 times x2. Does that make sense? This value right here is this up here. This value right here is this up here. This value right here is this up here. Does that make sense? And then, yep. Anisha, 50 points right there. Anisha's right. Then we're going to sum them. And we should get one value from this. And so now everything right here, this whole thing right here, it doesn't matter if it continues out, like if you had more, it would do it in this function right here. This is going to multiply the first position times of the first vector times the first position of the second vector. So it's literally going to do this process right here, and we see it right here accomplishing this, because 4 times 1 is 4, 9 times 7 is 63. So you can look at the mathematics right here. 3 times 5 is 15, and then you're going to sum all these up by doing the sum here. So we've now turned this into code right here. So let's go ahead and take this and put that to code. First part done. Now we're going to extract this and turn this into code. From here, it gets a little bit easier when we look at this and what we're turning into code. We've got the square root. So that's going to square root, but let's look at the inner part of this. Let's kind of space it out a little bit and, wait. We're breaking things. So we're just kind of making this easier to look at right here. So what are we doing to each element of x? What are we doing to each element of x right here? Kind of take a look and like, what are we doing to each element of x? And then what are we doing afterwards? We're taking each element of x1 and whatting it. Taking each element of x1 and we're squaring it. Yes, great job. We're squaring it, and there's the square. You can confirm it by looking at 4 squared is 16, 9 squared is 81, and summing it. Yep. We go here, we do this, and we go to sum, and there it is. And that's just the sum of that vector. So we're going to take, and we're going to replace this right here, and guess what? The really awesome thing is this. If you look at this, this is exactly the same, except this right here is just having x2 in there. So the only difference between this and the other one is it's this. So now we're going to take, and we're just going to grab all this and replace it with this. And what we should get, I think it gives the test case. I think, are we missing a parentheses? We seem to be. Okay, good. So it was a parentheses was missing. And now D should be this right here. Is that correct? Uh-oh. We have a mistake. We have made a mistake. Let's slow it down and see what that mistake is. Hopefully, maybe someone sees it. Hey, Adam, what's happening? Lots of great questions right now. We're going to do as many as we can, so stay tuned. So it's saying D should be this. That's what D is, and we made an error. I think it's in one of our parentheses. I think. So that's that. That's evaluating. Let me evaluate this. Here's what you can do. Let's see if the bottom is evaluating correctly. Oops, we're missing a parentheses. So that's 889, and this should evaluate the same thing. That's where an error is. Do you guys see it? Anisha has it right here. Where did I make the error, Anisha? Where did I make the error? It's on the top part of it. Here, we'll put this right here for the moment, and then delete it out of the chat so no one can see it. So that is the... I squared it, right? Squaring is the same thing as doing that. Sum of this... Am I missing a parentheses on it? Anisha, 100 points. Good corrections right there. And then this you have with this right here. So that's right. The bottom part of it has an error, which is where I thought the error might be. Oh, wait a minute. Oh my gosh. Anisha, I see it. Do you see it? We didn't do something. We didn't do something. We didn't square root it. So we didn't square root it. And so I'm just adding these inside of a square root right here. So there we go right there. And now I've got a parentheses off or something. So that's there. And that's there. Okay. And then it's mad about this. That worked. There we go. There we go. So now both of our equations return the same thing. And this is Anisha's equation down here. And so we can check. Oh, no, that wasn't hers. And then just delete it out of the chat. Yay! Oh, and then you have the sum of, you didn't do the 1 minus. So it needs to be D save into 1 minus sum of that. And if you notice the small differences right here, let's show it. We'll store mine into E, and we'll store Anisha's into D. And then we do that. And then we go, does E equal D? And the answer is true. So both of our codes are doing the same thing. Once again, do not write down everything I'm writing down right here. But this is just me checking that Anisha and I are getting the same thing. Does that make sense? What I've done, everyone, is I ran my code, stored it into E, I ran Anisha's code, stored it into D, and I checked to see if they're the same, which I could have just looked at them. They're right there on the screen. But they're doing the same thing. Awesome. Great work, Anisha. Excellent work. And it's so easy to make an error. I do something too quickly. I don't notice a square root, and then boom, everything falls out of control. But hey, it happens. For 320, I think my function was printing. However, is there a way for me to bold it so I can differentiate between the two lists? Kind of. Really good question there. Do it in Word afterwards. That's the easiest way. But there is ways inside of R, and I'll show you that probably in a little bit here, Alex, because there's a really cool way that if you want with your output to put it into your Word document, you can, and I have to remember it. So, and I'll look here. Let me get the paste bin open, and I'll take a look at this here in a moment. So I've got that open if you want to remove it. So I've already got your code open, and great, so great to see everybody here. I'm so glad we did office hours, because now we're going to take this right here. We're going to take this function, and we're going to turn it into a function. This is one of the big things you need to know instantaneously. We're probably going to jump to a new question here in a moment. But when you turn something into a function, you start by writing fun, because F is friends who do stuff together. U is for ukulele. And now you need the inputs. What are going to be the two inputs for this function? What are going to be the two inputs to this function? And this should get everyone very much started on this function right here. What are the two inputs? Yep. And we can confirm this. We're going to do x1 and x2. And then if we go here and it's called cosine distance or something, I think we've got, there we go. So it's actually probably going to work with what we have right there, not add to. Where is my function? Oh, here's my function. So we've created the cosine distance function, and I've got a whole bunch of stuff on here. So now, there's a thing right there. If I go down here to this cosine distance, it'll actually run and print that right there. But then there's some errors we need. So we actually have the first part done, but also outputs your custom warning, as well as the second one that R makes. So this one is if your vectors are of different lengths. So we need to go inside of our function right here, and we need to check the length somebody, and was that a warning or an error? Outputs your custom warning message, I think, right? But outputs a custom warning message. Okay, so we're gonna make a custom warning message that tells someone something. This is gonna be a conditional. What should I start writing if I wanna do a like custom warning message inside this function? What should I start if I want a conditional thing right here? What should I do if I want a conditional? If. Yep. I'm going to go if, and I'm going to go if, and then I want to check, like I want to check this of the things. I want to check this. I want to check this of them. Someone help me out. 50 points. 50 points. All those people type in if. Crazy office hours points today. I want to check the this of the functions. The length. That's it. There we go. Length of x1, and we're going to see if it's not equal to length of x2. Now, the way this works is this thing that I'm doing will only evaluate if these things are not equal. And gosh, I hate it when I do that. I don't even know how I do that so often. But this function right here will only run this code if they're not equal. So we're going to put warning, and we'll put like, really? You should use equal length vectors. And we'll extend the screen out. No, we're fine. So that's got it going right there. And you could probably do this. There we go. So that should run, how do I understand? Yep. And then we go down here to check. And so this one right here can be checked with the following. And you see we get our custom error message, warning number 1, and then we get ours message. So we get the really, you should really do this, and it prints it out for us. And you look at how that was created. It was created with this if. And once again, all I did was hit enter right here to start a new line just because I wanted to see it on a separate line. And you can do that because it'll read through to the next argument. So we're able to create our custom warning message inside of there and get it going. Do people feel a lot better about this one? It's not that many steps from here to finish it up, and we'll see who said the next one, but hopefully this gets people really started on this one. And then the next one, we'll do a 321 right here. 320 question 5, 320 question 5, I think it is. Good job. Awesome work. And we can come back to this one and work on some more, but let's do some 320 question 5. I think it's right here. So let's hop over to 320. Wait. Maybe I need to load 320. Do I not have it open? Did I delete it all? 320 question 5. Here it is right here. Cool. Some people emailed me about core demo. I saw it and I haven't replied to emails because I've been in meetings. Sorry about that. If core demo is not working for you, I'll probably be sending you to this portion of the video. So hello for a person. If you try to run core demo in a chunk, it'll crash. So if you go here to core demo and try to run it up, oh, it does run. Hey, maybe, because mine sends it to a new plot window. But yours might have crashed. You're like, hey, Brian, that's not fair. So if core demo is not working for you, then go right here and take your core demo and put it down here. So if core demo is not working for you, mine opens up in the plot windows. Yours is probably trying to open up in the window below. Go here and run core demo. If you want to change your plots so that they don't open up in the window below, go to Tools, Global Options, go to R Markdown, and then yours is probably checked with this. Yours probably has Show Output in Line, which will show it down here below it. So yours probably has this clicked, which then tries to open it up down here, which it can't do the core demo there. So if you unclick this and then go down here, you have to scroll down now and go to Apply and Save, you can now actually run it up here. It'll run and it'll open up in this window. Make sure when you're running core demo, this is a huge thing though, you have to hit finish. You need to finish. If you don't hit finish, let me show you what happens. When you're running core demo, if you try to run stuff over here, you just say, Brian, nothing has been running. Brian, what's going on? It's just stuck. It's currently using core demo, and then we finish, and it runs all that nonsense code I just ran in the background right there. So I've seen a lot of people get stuck inside of core demo and not know what's going on. So I'll probably be sending people to this portion of the video, but hopefully that'll help you out. The easiest way if you're trying to run core demo is just to go here and run core demo, and that'll work for everybody. Yes, when you're running it down here, the other error you can get, here's the other error. Ryan, 50 points. Thank you for pointing that out. Are you getting this error? Are you getting that error? And that's the error right there. Are you getting that error right there? If you're getting that error, it's because the window is too small. That's the only other error I can think of. Tell me if you're getting a different error. There's only other one possible one. The only other possible one is reg class is not loaded up. Oh, there it is. Yep. That was it. Here you go. There you go, run that. SE have a negative. Is that for core demo? So is that an error you get with core demo, Nicole? Because I don't think I've seen that one. All of a sudden now people are like, take on this error, Brian. And I'm like, oh no, I didn't know that error. It says that. What is it? That's like standard error. Have a negative. I don't know. Send me a screenshot of that very soon. If you can send it to me now, that'd be even better. Send me a screenshot of that, and I'll get that figured out, because you just stumped me. 50 points, Nicole, right there. Stumping Ryan. I don't know that error. I don't know it off the top of my head. So I'll have to look at it and be like, I don't know what's going on. But Ryan running library red class should get it working. And then also you can't knit this right here. And so let's go down to the questions on this. Using core demo, generate a scatter plot with a correlation of -0.8 plus or minus this amount. Have this correlation be displayed in the upper right corner, in the upper right up here. Once this has been done, click the export button right above the plot, save the image, and then you can just insert it into your Word document. My best advice to people is to just put these into your Word document afterwards. Don't worry about using these codes right here. I mean, if you title them correctly, they'll go in, but people make mistakes. I mean, you can do that, but if you just put it into your Word document, you're good. So here we go. Got to make it weaker. If you want to make a correlation weaker, you put the points further out, and it doesn't give any things about it has to be like Pearson or anything like that, but it just says that it needs to have, -0.8. Oh, no. We can undo. No. So we want -0.8. And -0.8, can I not undo that last point? Well, that's a bummer. Well, I can probably get -0.8 with this. I'm just going to have to, there we go. It's heteroscedastic, but I can get a -0.8. I just need to keep going in closer in here. And probably if oh, there it is. That's got it. I want exactly it though. Oh, it's so close. There we go. That's got it. It's heteroscedastic though. You can see the heteroscedasticity right here, but it doesn't say anything about it doesn't say it can't be. You can save it with this method, but it's much easier to just you could literally just go to snipping tool. Here's my best suggestion. I'd go snipping tool, and now my screen is frozen. I'm going to go here. I'm going to grab this. I'm going to go over to my Word document. I might even just place them here for after I knit. So, that's our image. So I might just take the image and just drop it over here and just put it into Word, and you could readjust. Always grab the edges of a picture. But you could take this, and if you go to wrap text in front of text or behind either or, you can then move it freely. Watch out. Do these things last. Don't start because it'll move text around. So be very careful. Just put images in last, I generally find. And it's at top right corner, but that's still within plus or minus 0.02. So if I really want to be very, very, very specific, I could go back to here, and now they're both it. It's awesome. Does this make sense how to use these plots? Is there another one? I'll do one more of these. You guys can pick A, B, or C. Oh, I'm going to do 2 out of 3. Oh, okay, cool. What do you want for, here, let end, and now we'll do another core demo. And what do you want? Can you do one with a stream requirement? Oh, is there one with a stream requirement? What's it say? During a scatter plot which has a stream of points with an extreme outlier. Without the outlier, red dot, the stream should have a correlation of this. Okay. So here's the correlation it should have. Hey, what's up, Tyler? So good to see you, man. So good to see you, Tyler. Man, love people swinging by. Just, I miss you guys. I miss you, Tyler. Miss you in class. You were 474 last semester, right? 474 fall? I mean spring? I don't know what day it is anymore. I don't know what day it is. I don't know what year it is. I'm just hoping I can convince my parents. Yeah, spring. I can see you in class, Tyler. Like when you know class existed. N320, yeah. I miss you guys, front row, right side of 474, right? Front row, right side, right? Is that right, Tyler? Front row, right side, fourth. Is that right? Tell you I know you people. I know everybody every day. Yeah, of course. I know you sit in the front row. I know where you sit. Front row, right side. Man, I miss looking out in the audience. I miss it. I love teaching online, but I mean, it's not the same. I love it. It's it's fun. I get to see you guys, talk to you guys here. Oof, I entered in too many points. The stream should have a correlation near this with the outlier. You can always swing by and you can always say, hey, and look, you got some love from Tyler right there. Tyler knows to check his points. You're about to see some crazy points. People got some crazy points going on here. We've been going crazy, and I connected Tyler. You're about to see, if people like Andrew check their points, you're about to see whoa, the madness of the points is going crazy in this room. Andrew's about to flex on you with those points. So, so close. I don't think I can do this one because I have too many points. So the goal to this one, here's the trick to this one. And then we'll do another 474 to this. So I've been giving them extra points, adding it in. Oh, you didn't? But you did get your points for a class, right? Did you? the certain things didn't work. Oh yeah, when I tried to add in points, like we've been figuring out what's broken. So I'm sorry if I like Tyler came in here and be like, Brian, you never gave me those points. Up, look at this, look at this. Now it has a 0.7 correlation. People are just they're like, look at these points. Here we go, here we go. Look at this. Oh man, we got to go for perfect here. We got to go perfect. Oh, it's world record right there. I know. Great job, everybody. Great job on those points. People are working really hard, like competing. Here, let me go. I'm going to give Tyler Young some points. Here, wait. 2 seconds. Tyler's serious right here. Tyler, don't check your points yet. Tyler, don't check your points. Don't check your points yet. I'm making it up, Tyler. Tyler, check your points. I'm teaching more classes. Go ahead, Tyler, check your points now. Show everyone, just show them what's up with those points, Tyler. Show them what's up with those points. Be like, oh, you thought. You only heard 5? Clackety clack keyboard. So, oh, Tyler, damn. Got a lot of points there. I know, right? I control all the points. Yeah, you're awesome, Tyler. Yeah, swing by anytime, Tyler. It's such a pleasure to see. You know, I think people know that like I have a lot of fun with this, and it really you guys make it. What are your secrets? I love it. I love it. So we did some 320 right there. Let's hop back to 474. Number 7 on 474. Ninton, you got it. Let's do it. Okay, number 7, 474. Let's hop back to 474. Okay. Oh, cool. Is this the card one? Am I the right one? Is this the card one, Ninton? What is? Oh, that's chunk 7. Chunk 7. What am I doing? Okay. A spatial moving average is similar to a moving average calculated for a time series. Ooh, I think Ninton, I think you chose a really tough one. I spend 23 hours a day on data camp. Yeah. Oh, yeah. That's data camp. They just got their data camp for moving. So we're doing a spatial moving average. Example 5 on the slides. Yada, yada, yada. So instead of averaging together the current value of a time series within, say, the 3 that came before it and after. So when you think about a time series, you can do like the plus or minus 3 on it. And so this will be really good help for Jordan and everyone. This is like a plus or minus 3 moving average. It's talking about that. It's saying instead of doing that, a spatial moving average finds the average value in a window of nearby locations. Okay. So I think we were doing that. Oh, and so I think this is the picture one, isn't it? This one's a fun one. And so right here, is it already written? Am I looking at the answers? No. Do not change this to generate the data for the problem. Yeah, of course. Okay. And then makes this image right here. Yeah, this one's super cool. This one's really tough. Good question on this one. And so a spatial moving average is similar to, we already read that, right? And for example, consider the matrix M from the chunk of the code above. The matrix has a plotted image. There is behind me. There are 50 rows and 50 columns. And so you can see the little dots, little pixelated image, but the plot axis labels it 0 through 1. There they are. Red is a cold, represents a smaller value. Purple, blue is hot, represents larger values. There's a color peak in the values near the center of the plot, but it looks like maybe there's 2 peaks. There you go. The image is noisy since colors in the adjacent cells can sometimes be rather different from each other. Perhaps we can get a clearer picture if we examined a spatial moving average. Let's consider a moving average to be a half window of size 2. Okay, so what's this half window thing? Stat Nation, Keaton, so good to see you. Look at this. We got a moving window here, and what we're going to do is we're going to go up and down around it and left and right, if I remember correctly. This means the moving average calculates the value in the 15th row and 20th column, for example, would be the average of the 25 values, 2 elements to the left, right, and up and down. See the output in the chunk below. Okay. So this is showing us exactly how to do it. So we're making a smaller matrix here of values. You see how it's 25 values? It's including the original like 15 and 20. Let me show this right here visually, because you have to see what this is doing. It's creating a window. It's a spatial window around it. And so this is such a cool problem. And so what it's doing with this spatial window is it's going at the current value here. That's the current value of one of our coordinates and one of the coordinates here. And so it's going up and down. Keaton, so good to see you. And it's going up to down to, out to, this way. And this value right here is the value of the what. I need someone to help me out. This value of 2 is the value of what. We just saw it in the problem. This value of 2 is the value of the what. That value of 2 is the value of the what. It was just in the problem. Just saw it. It's like that thing you look outside of. And it's half of it. Boom, half window right there. That's the half window. And just think about what this means. Like, so think about what this means right here. 50 points, all those answers and guesses. It's half the window. Like when you look at the window right here, this is a half window. Does it make sense to call this like a half of a window? It's half of the direction in the window in one of the directions. We've got the up down direction, we've got the left right direction, and if you go up or down, left or right, any which way you do this, this is half of the window. And it is kind of like a bit of a cluster. Like we're taking almost like in step 1 like a cluster sample by taking all this area out of here. So this is a half window right here. Let's go back. Yes, I want to remove that. And this right here is the really big important thing, is that we're taking the mean of this window. So that just takes the mean of all those values. And so we've done it. And think about this. What you're doing is you're going to like make a window in here, and then you're going to like blend together how hot or cold it is. So it's kind of like smooth it out. It's like it's going to be less and less kind of jagged across. Like this area in here will be more green, and this will be more like red, and this will be more like yellow. It'll like smooth it out. Like if we could do finer pixelations between it, we would see like a smoothing of the colors. And if you were to do a window that was 25, what if you did a half window of 25? How many blocks would be in here then? 100-point question. If you did a half window of 25, because remember it's 50, how many blocks would be in here if you did a half window of 25? How many blocks would you end up at the end if you did a half window of 25? So you'd go 25 one way, 25 the other way, and how many blocks would you have at the end of this? 100-point bonus question. How many blocks? Good guess. I'll take that as a guess right there. Anisha and Madeline, you both get 100. The answer is you'd have 1, because the half window, there's 50 here, there's 50 blocks across here, and there's 50 blocks this way up. So if you were to start here, which is the only block you could take is the middle block, and then you'd go 25 blocks this way, 25 blocks this way, and you'd go 25 blocks up. To show, because I want you to understand visually what we're doing in this problem, like it helps if you understand visually and mechanically what you're doing, is in this problem, we are making little half windows in this diagram. We're going here and doing like a half window, and then we're averaging together all of this, and then that's going to be the color of the point in there. And then we go here, and we make a half window, and we average together that, and we just keep going through algorithmically making these windows and averaging together the points. So if you were to have a half window of 25, you would have to have the full thing, and you would only get like this 1 point averaged right there. So it's a little bit, that's a trick question right there, but understanding what the algorithm's going to do, and so it's going to reduce the amount of blocks in here by how big our half window is. So we're going to lose a certain amount of the pixels because you're going to recode the colors of the pixels based on the average of the half window when you average it together. And so just visually what it looks like again, just to see the previous one, yep, I thought I just reached it, is we're taking the data in a certain range, and then we're going to average it together. So we're going out a half window up or down. So when you think about this coding-wise, we basically have a big chunk of the code. A big chunk of the code is this right here. And where would this store into? So we're going to create a thing called M averages as a copy of M. So we're going to copy M, and that's the first step right there. So we're going to copy M into, because that's the matrix, we're going to copy our matrix into M.averages, which oh yeah, we got to make it. It doesn't exist. That's why we're making it. Now it exists. Now if I type M.averages, it will exist. So now we have M.averages, and it's just a copy of the values in there. Remember, this is a colorized visualization of the value of the points. So we're visualizing the degree of the number, like how large or small it is. Higher numbers are redder, I think, or bluer. It's just a color based on the numbers. You could look towards the middle. There's a small number down the bottom right corner, so that looks to be, that's that color there. Go up here to the top right corner. You can see all the difference in colors. And so now here's the big part. Do not modify the code. Do not do that. Use a nested for loops. We need to do a nested for loop. Okay. So this is where it gets tricky. I want us to look at this code right here because this is the important thing. And we are going to use a nested for loop to define each element of m dot average as the spatial moving average with a half window of 2. Start with the third row column and end with the 48th row column, since you can't calculate the values of m average in the first, second, 49th, and 50th. Why can't we do this? Why can't we do this? I want you to look at the equation right here, and someone saying words for 100 points. Why can't we start at the first row? Why can't we start at the first row or the first column? Why are we stopping at the, why are we going to the 48th? Why are we starting at the third? Yeah, the -2. Because if you were to start at the first, exactly 1 minus 2 doesn't exist. We'd be going outside the matrix. So, which would be cool. Matrix 4 coming out. Man, Keanu Reeves got like, oh, Matrix 4. It better be good. Keanu, don't let me down. You never let me down before, Keanu. There's no bad Keanu Reeves movie. I stand by that. And I'm sure there is. I don't know. He's been pretty good. He's got a Keanu Reeves vibe to him, but you know, he's got a good track record, and he seems like a pretty cool guy. I don't know Keanu Reeves, but you know how it goes. So what I'm gonna do is I'm gonna call this row and columns right here, and instead I'm just gonna run it on the 15 and the 20th. Okay. So what I'm doing right here is I'm making sure this works, and this will work right now. So that does work. Does everyone understand that this does work? And what am I coding right now for my for loops? You got to say it again. I need you guys' help. What am I coding for my for loop by writing it this way? What am I coding for my for loop by writing it this way? What am I coding? Skeleton, boom, 50 points right there, throwing out some crazy points. You can get up to 200 points in these crazy office hours. This is your skeleton right here. And all that's going to change is we need to do a nested for loop, which sounds crazy, but it's not that bad. We're just going to go here and go for. Where's my for loop? There we go. Oops. Give me the for loop. There we go. Okay. So now when you look at this, I'm going to put it here for row and column, row and column. This was row. Please note, why am I changing? Do you see why having 15 here helps me know that this is 15? And this is the rows and the columns. Good. Because this is the row space. This is the mean, like we're going inside of the matrix. Joke's never going to go on. This is the rows right here, and these are the columns. If it helps you see it just smaller, this is the row space, this is the column space, and the comma separates them. So when I go right here, I'm changing 15 to row, and this to row, and this to row, so that's going to change what row I'm in. And 20, which is right here, is going to change to column, and this is going to change to, nope. This is going to change to column, and this is going to change to column. And that's going to create the half window inside of there. So mine says incorrect number of dimensions. But then I think I know what the big thing might be. So which, you might just drop your code in the chat and then remove it afterwards, but drop your code in the chat, Vedrina, and then we'll see what's going on. We'll see if we can fix it. This is row, this is column, and then it needs to go from, whoops, column, and this is going to go from 3 to 48. Watch mine not work either. It happens. Code doesn't work sometimes, and that happens. And does that work? It works. Do we get the sanity check? Hopefully we do. Object, oh, did I not do a capital? Cool. Let's call it what it calls it, just to be for sanity check's sake. And we got it. There's sanity check. We did it. The biggest thing, the hardest part about this was probably coding the skeleton and knowing where to find it and kind of understanding algorithmically what it's doing. Oh, if it's saying too many dimensions, you must have another comma inside of here. That's where it's going to, there must be some sort of comma. This is where the error is going to be. Your error is going to be right in here, or your error could be in here. One of the two, either you've put an extra comma here, or you have an extra comma there. Have you created M yet? Have you created M? Run this line of code all the way back here. Make sure you've run this, because I bet, let me try something. Object S not found. Run this line of code up here, because that creates object M, and then M should have, this should work for M. Awesome. Great job. 50 points right there. Thank you for telling me it's wrong. Don't worry. Just be like, hey, it's not working. And object M looked to be not created, because you are pulling 2 dimensions from it. So it's a 2-dimensional object when created. That does it right there. Your task is likely something you would do with visuals for the half window. MB is a new matrix to find our chunk. Write a function called matrix smoother. A matrix, it takes a matrix M. So this is argument 1. That's argument 2. what do you notice about our for loop? Our for loop right here looks to take this, and it looks to take this. And that's the answer to the function. Do people feel a little bit better about 7? I might stop on 7 there, but literally I'm pointing to this is your matrix, and this is your half window. And so then it's already got a lot of this in here, but here's the problem. Here, I'm gonna do a huge help on the function. I'm gonna code this as this, and I guess you'd need to go, let me see if this works, and call m minus 2. That should work. And this is the row, so this is 1 plus 2. This is a huge help. This is like the biggest help I could give on an n row. I think you do make minus 2. As long as this works, we're good. And we make sure it works over here, and then we do the sanity check, and we look to be good. What am I doing by doing this? Why would I code it this way? Why would I change my coding right here? Because what have I separated out from the mathematics now? What have I separated out? And this is big. I'm probably going to stop this one here because I've basically turned it into a function, or I've made it very easy. Like if you know how to turn into a function, it's pretty much worked for you right now. What have I separated out? Like help in the chat and tell us what Brian has separated out right here and pulled out that we just need to recode. I mean, it's highlighting all of them for you. And that was our what? It's down here in the, my computer is being weird today. It's down here somewhere. It's telling us that we have 2 arguments we need to input, and I've kind of separated that out so that it can algorithmically change that, and it can change based on what we're doing. Yep, Adam, you're right. Does it make sense, Adam, what to do from here? That this is just going to go into a function, and I would go in here and put returns around this. So when it's in a function, I'd put the return on it. So then that would return that object at the end of the function. Actually, you know what? I would not put it there, though. I'd go here at the end of the function, and I'd go to return and do that afterwards. Don't put return on it, or when it goes into the for loop, I think it'll return. I think it'll go into the for loop, run it one time, and return it then. Maybe, I don't know. I'd put the return outside the for loop, let the for loop create it, and then return it. But does that make sense, everybody? This is the majority of the function written, just needs to be dropped into a function and needs to be changed, and that's the harder parts of this problem, I think, completed. How's that looking? I think 2 people wanted me to work on this. Let's see here. I think that was, let's see here. If that helped out, good stuff right there. Does that look pretty good? We're going to do another 320. I had to be away from keyboard. Were you able to review the bolding in cat? Yeah, and Jordan, awesome, Jordan. So you have your code you sent me, right? Let me look at that code real quick. And let's look at that code. Okay. Oh, you want to bold in cat, right? Okay, so you want to cat something and bold it. Let's see. Is that possible? I've never tried this. This is Brian's quick little, and so you have right here the strongest 5 of that. So you want to bold something that it cats out. Paste with bold in R. I think we might need to paste. How do I use a bold text and use in Paint in R? What here? Oh, whoa. Okay, we'll try this format right here. Okay, let me try this. It's using HTML stuff is what it's using. And so let's see if that runs. This just might break it. And it did that. It did that right there. That's not what we want. So let's try this. Let's go to paste. And let's just see what it does when we run this, if we can do it with the paste. So now we get the paste options on it. And I don't see it. Did it just destroy it? Oh, because maybe we need to cat paste. This should not break it now, though. Well, oh, someone's asking. Oh, that's in Shiny. That's in Shiny. That only works in Shiny. So they're doing it in Shiny. Okay, maybe I don't know the answer. Bold and paste function. Print quote F. Okay, wait, 2 seconds. Did no one answer this one? Someone asked the question. I know a totally different way of doing it. How to get empty text with partial bold. Empty text. Font 2. Okay, wait. Okay, wait. empty text. Complex text editing can be done with expression. Let's see what this does. It's my last try on this real quick here. Let me put this here to see if this runs. Never tried this. No. It's, yeah, I don't, I think that's, your code for 4 isn't working. We can take a look at that. So we got a 474 right here. And so question 3 for 474, and Adam, we can do that one next. I know I like Alex. I have too much fun with that stuff. Like I could spend the next 20 minutes trying to figure that out. There's ways. I've got another way. I really want to figure that out. So let's go ahead and look at Adam. Which one's Samir? Could you go over? Yeah, number 1. Yeah. So we got to switch to 320 real quick. Let's hop to 320, and then we'll do another 474 here. So we're gonna go to 320 because I'm gonna try to do each class back and forth to give equal time. And question 1. Okay. So for question 1, I believe we're analyzing response rate. And so for response rate right here, we're going to do the response rate and we're going to look at all correlations. So I'm going to throw in a chunk right here to help out. Never hurts. You can just add in your own chunk. And I'm going to call this investigating correlation. I think it's correlation spelled like that. And we need library reg class. And then we're going to go here to data ex2 census. There we go. I loaded some more data sets. And so we got data ex2 census on here. Now, the function we need to know is all correlations. Okay, I need someone to tell me in the chat, what does all correlations do again? What does it find for us? I need to know. What's it going to find for us? What is all correlations going to find for us? I need to know. What does all correlations find? It takes a data frame. So the data frame is the input. Here's the data frame input. And it finds for 100 points, 200 points max office hours a day, finds all, what does all correlations finds? Yep, finds correlation. You got it right there, both Sarah and Adam. It finds all the correlation. It finds every single possible correlation. But we don't want to find every single one of them. We only want response rate. So if we only want response rate, we need to go here to interest. So interest right there. You got it, 100 points. Vader, excellent work. Response rate. And this is only going to give us the response rate. So if you look at this right here, we now only have the correlations with response rate. Now, if you get stuck on how to use this, I'll disappear. You can always go over here and go to question mark all correlations. Now, it'll show you a kind of how to use this over here in the corner. And it's always a good help to know these things exist. We have the options of sorted right here. And you would think the option we want is strength, but we actually want to do magnitude. Magnitude is going to sort this by the most absolute value. Yep, Ryan, excellent work. 100 points there, Ryan. Sorted equals quote, it has to be in quotes, magnitude. Now, once you make output, always look at your output. Always be like, is this sorted with the highest or the most absolute value correlation to the lowest? And we're just going to show it all on one page so it doesn't show anything else. This is the highest absolute value of correlation, and this is the second highest, going down here to the weakest, which are closest to 0. And the p-values also get weaker, as you notice. So they're weaker as in closer to 1. So the strongest p-value is closest to 0, and it actually estimates this p-value at 0 because it's ridiculously strong correlation. I think that's got the first part right there, which we did in the last assignment as a bonus. But now I think question B asks, where's question B? I'm off the screen. Question B. Question B asks, the variable most correlated with response rate is homeowner HH. What fraction of the householders own their home? Calculate R squared and interprets its value. So how would we calculate R squared? And I need someone to put, I'll let you put this answer in the chat. Well, how are we going to calculate R squared? How would we interpret its value? You can put this answer in the chat for those watching. R squared is R squared. Yep, R squared is R squared. And now, what does this mean? We're trying to understand what. And so I need a really good answer. Let someone break the rules and get 300. I need a good answer of what the R squared is right here. Like, what's the interpretation? Remember, we're using homeowner HH and response rate. And the value of the correlation is, I'll grab it. It's homeowner HH. I mean, not the value of the correlation, the R squared. So I'm not going to write the answer in here, but you guys can write in the chat. But that's it. And then you turn it to this. So it needs to be changed into a percentage. So what is this going to be right here? What is that? What is that right there? What is R squared? What does R squared mean? What the heck is R squared? What is R squared? So we got homeowner HH. What is r squared? I might let you guys think through that. It's like, what does this mean? It's in the notes a lot. There's some really good stuff in the notes on that. And so, close. Here we go. Vader now. Great work. 41.65% of the variation in homeowner HH can be explained the variation. Switch them. Just switch your member X explains. Perfect right there. But just switch it. It's that 41.65% of the variation in response rate. But here's the thing. Since it's X and Y, you can flip them. But if we're talking like we want to understand the response rate to be 41.65% of the variation in response rate can be explained by the variation in homeowner HH. So just flip the variables, just depending on what you want to call X and what you want to call Y. The Y is what you want to understand, and the X does the explaining. So since we're interested in, you'd say, well, how do we know since we're interested in this? And my contact is going crazy on camera. R is giving me an error when I'm trying to store m.1 in 7. You might have to email me or drop your code, Jordan, and then I'll look at that next. I'll finish this one, and then I'll hop back to that. Part D is really tripping me out. Let's hop down to Part D. Let's do that. Part D, what do we say to Part D? Oh, we did that in 201. We don't get to say it in our class. We'd look at 201. In 201, we were like, what do we say to my peers? And we say, not today. So you know what we're saying in this problem? We're saying, not today, Part D, not today. Explore the association between log median house value, the log value of median household income, and this value right here. Okay. Use the associate function right here. Describe the direction and form. Okay, what are the possible directions? What are the possible directions? That. So I think I see the issue. I'll come back to it here, Jordan. I see some big issues with that. I'll come back to it. You got it, though. Good work on it. How many? Oh, no. Oh, no, I need to change that. It should be 2. Grades are going to change. Grades are going to change. Caroline, thank you. Caroline, 100 points. Sorry, I didn't change that from last semester. Sometimes we drop an additional one because there's sometimes a bonus one. But right now it's 2. Sorry about that. I didn't notice that was not changed because last semester, as you know, got crazy. And then I taught mini-term, and then I taught this. There hasn't been what literally happened is I think I gave my final, and then mini-term was like a day or 2 later. And then for those in 201 mini-term, we had our last day of mini-term, and then the next day if we can't get to a certain assignment, I offer it as bonus, and that's the way it was. So there is the chance for 3 drops. Don't plan on it. There'll probably be 2 drops. I mean, like, there is at least 2 drops. So I will fix that. So sorry if anyone sees their grade change. But I will change that. And I don't get to tell if that's for 320 or 474. But we do 2 drops, and then if there needs to, like, if we don't get to an assignment, I just offer it as bonus. So that way the people who want to do it can do it. It's like, hey, if you want, this assignment exists, but you don't have to because we didn't really get to the material. The associate function. We need to do, and so when we do associate, and we're going to help ourselves out, we're going to run here, we're going to go attach. With attach, it attaches the data frame. And so it attaches the data frame to allow us to type. And what did it want? Between this and this, let X be median home. Okay. And let Y be log. Okay. So we're going to go here and we're going to type log. There it is right there. And then we're going to type median. And was it city? Was it city or block? It's city. Okay, good. I think we have the 2 values. I got to make sure I don't make an error, lest if people are watching, they make the same error. And so now, technically, this probably will work. Don't do that. Practice good coding. Do this right here. Now, you might be saying, why is it not y tilde x comma data equals? I did a trick. The trick I did was I used attach. If you attach a data frame to the global environment, you can actually access them. So this right here is a really good review question of this right here. Okay. So when we look at this right here, random phone call. When we look at this right here, what's the first thing we ask if we're going to do correlation? I need some help. I'm stuck. I'll go talk to the random phone people. What is the first thing we should ask when we're doing correlation? Follow the flowchart. Post it to Canvas. Yep. Are they quantitative? Quantitative. Pretty much quantifiable, but like quantitative. So are they both quantitative? And the answer is yes. So we can continue on. They are both quantitative. We're good on that. And now we say, Is the relationship monotonic? What does that mean? What's your favorite band again? I need to hear that favorite band. What's your favorite band? Is this your favorite band? It does look like my favorite band. One Direction. 100 points right there, Ryan. I just like saying that. I was like the student last semester who said it, or was it Andrew? Andrew said, not Andrew Wynn, another Andrew said it. And he just looked and he's like, One Direction. I was like, that's your favorite band? He's like, yeah. so there we go right there. And it goes in one direction. So this is monotonic. Think mono is one and the direction is tonic. So this is monotonic. And is it linear? That's how I feel about that. I feel like, yeah, no. It's not linear. That's not linear. So that's a problem. That automatically puts us over here. Are there no outliers? That one. I mean, the bigger problem here is the non-linear nature. There's outliers-ish. I mean, like, the degree to which there's outliers, yeah, those are outliers, but, I mean, the non-monotonic is worse. Is there heteroscedasticity or homoscedasticity? Homoscedasticity means same spread, like it should have the same thickness throughout. Like I'm showing you like a plot and we're looking at the thickness of it. And then heteroscedastic means it has a differing thickness. It doesn't have to get thicker or thinner. It just has to differ. Like it could get thicker, it could get thinner, it could get thicker than thinner, than thicker than thinner. But differing spread is the problem. You want equal strength, and the strength is the thickness of the plot. So we don't want unequal strength, unequal variances, heteroscedastic relationships. Those are all the same things if you hear it through multiple disciplines. And maybe that's a good, I mean, yeah, it's thicker here. There's less points out here. That was on a graduate level course. I got points off because Dr. May, love him still. And I still remember the answer to it. He showed me a plot like this, and he was like, well, there's fewer points, and fewer points mean fewer scatter. So yes, you're going to see more scatter where there's more points. So is this really heteroscedastic? I mean, we can see it. There is definitely a non-linear nature to this. I'm not so convinced of the heteroscedastic nature of it. So I would say the biggest evidence right here is the non-linearity to it. So if we think about how this question was asked right here, and we'll jump back to 474 after this. Thank you, everybody, for coming by and working hard today. Explore the association between the two. Describe the direction. It's positive. And describe the form. It's linear, non-monotonic. Do you see any unusual features? There were some outliers. And what is the best measure? And then explicitly why, I'd probably say it was one reason. What was the best measure, Spearman or Pearson? No, Ryan, that's awesome. Now it makes sense. No, don't worry. I'm glad. Now you're like, oh, it makes sense. That's what it just sometimes like when it clicks, you just got to like repeat it. You got to like think it. You got to practice it. And like, it's just practice. So which one did you choose, Ryan, Spearman or Pearson? I know you got it. Ryan, 100 points. Which one did you choose? I know you got it. We will see. And then we'll do another 474. What was the other 474 one people wanted? People wanted a few more 474s. Okay, cool. I'll let you say which one you picked, and then I think you got it. What was another 474 people wanted? What was another 474? Q5B? And this just says Q5B. So people are saying 4, and there we go. We might do 4, and there we go. We got 4, Q3, and 5, Spearman. Yep, Ryan, you're right. Yep, Spearman. It's definitely Spearman. And I would lean on the non-linear relationship to it. There's really the biggest part of it is probably the non-linearity. So I'd lean on the non-linearity and be like, I really see some non-linearity to this. Go over here. Click over here. So the first one was question 4. Also get question 4. And this one right here, we are going to make a vector, write a vector called leaps. Have this function, and it takes 2 inputs. Now, you can add in chunks anywhere you want, and we could have this chunk not evaluate. So if you notice, I'm clicking here and going to show nothing, don't run code. So that'll make this chunk right here not do anything. We're going to write fun, and we're going to go leaps, not the position, and then we're going to put in the variables x and lag equals 1. This is part of this code right here. And hopefully this helps people out, but this is, like the code wrapper for it. Everyone was talking about that. There was a light flicker on campus. It said UT alerts. There was a power outage type thing. And, like, I was in a meeting and everyone's like, we just lost our power. Luckily I didn't. So you can't get your code to work correctly for this one. Have the function return the vector x. So return the value of x's leaps, defining as the absolute value of the difference between these. Okay, so let's take a look right here. You ready? We have to do this slowly. We have to go through this very slowly. Let's take this vector right here, and let's go down here to this code. Well, it's test vector right here. Okay, so if we were to do leaps 1, what it's going to do, I'm going to tell you how leaps 1 works. It goes right here to 5.1 to 4.9, and it takes the absolute distance. So it'll store in 0.2. Then it'll do this, and it'll store here 0.2, because that's the difference. Then it'll store here 0.1, because that's the difference. Then it'll store here 0.4, because that's the difference. Then it'll store here 0.4. If we do leaps 2, the first elements of leaps 2 will be what? If we do leaps 2, the first element of leaps 2 will be what? If we do leaps 2, the first element of leaps 2 will be what? Nope. Nope. No, got it. No. There we go, Adam. You're right. 0.4. Yep. Well, it's going to take the absolute distance between those numbers. Does that make sense? Leaps 2 of this vector will take the absolute distance between those two numbers. Does that? So every time you think of this, leaps 2 is going to do the first element's that. Will be the next element. Yep. Good job right there. Yep. This is why we practice. Will be the next one. Will be the next element of the leaps vector right here. Will be the next element. And it'll always do the absolute value of the different distances. Any ideas? Brian is stuck. I don't know. I can't math. 0.3, you got it. Nice job right there. And this is also 0.3. And then this is 0.8. Yeah. So it sounds like you're really close. So here we'll follow the steps along. Let's see if we get it. So we've got test 3 stored right here. I'm going to go here and I'm going to do this. Okay. So what I want to do is I want to take test 3. And what I want to do is I want to go and I want to take the first element minus the second element. And I want to take the absolute distance between these. And so this does it right here. So this is the first element minus the second element and takes the absolute distance of them. And I'm trying to think right here. Oh, and then we got a for loop it. Yeah. Okay. So we're going to do this right here. And then we're going to go through and we're just going to keep doing this. And we go the first element, second element, minus this. I think there's 5 elements total. Or, yeah, there's only, yeah. There we go. So now we have the first element minus second element. It's just going to store into here. And let's store it. We're going to call this leaps. Or we'll call it like, what's I want the output to be? Do I have a name for it? Separated by lag element. Is there a name for the vector it wants returned? We don't want to call it leaps. Let's just call it answer. So you can call it answer right there. It's 2 minus 1 first. Oh, it is? Oh, you could, but tomato. 50 points right there. I like that. And so since we're taking the absolute value, we can do it either way. So since we're taking the absolute value right here, either way works. So that's the biggest thing, is the absolute value we could do either or. So, but no, good point. It's saying do it that way, like the difference that way. So to do the spirit of the problem, we can do it this way. And we're going to store into here answer position 1. And then we go right here. And we go to answer position 2, answer position 3. Now, here's where it gets harder. Is what if we were doing leaps 2? What about this line would change right here if we were doing leaps 2? What about this line right here would change if we were doing leaps 2? What about this line would change if we were doing leaps 2? If we were doing leaps 2, what would go right here? If we're doing leaps 2, what would go right there? What would change if we were doing leaps 2? Because this is leaps 1 right now. 2 would be I plus like, yeah, and we can do that right there. And basically, I'm going to do this. And we could do this. You could do that. That, no. It needs to be that. What am I doing? So this right here, and then you're also setting it up correctly for later, because with the I, we have the placeholder. But this right here, and this would be 4, and this would be 4 here. So this right here is like, yep. And so they already have that using this as a skeleton right here. And this right here will still work. Oops, there's no answers, so we got to make that. I knew that, and I did the other part. And now that works. And we've stored into here the values of the leaps. So what have we now created? What have we now created with this right here? What have we now created? What have we now created? You guys know it. I got to hear it. What have we created? What is this? What is it? It's a skeleton. It's a skeleton. That's what we got right here. We got a skeleton. So let's go here. Let's go 4. FOR. No, I want the snippet. Give me the snippet. And then we go there, and we drop it in. Then we put in our placeholder. We put in the values it goes through. It goes through 1 through... This is where we got to be careful. This is where we're going to have a problem also, is we want to go through the length of test 3 minus lag. And right now we could go out here and we've got lag stored, but let's go lag and store into lag 2. And this is also going to cause a problem. That is going to cause a problem. That might have been your problem right there. And I think, and then this needs to be I. And then this needs to be I. I did it really quickly, so I'm afraid. Up. There we go. Oh, wait, it's got 0. Is it 0? Uh-oh, that's not good. Why is that 0? It's leaps 2, so it'd be that is that. That is that. Oof, something's going on right here. 1 plus lag. Oh, it's I plus lag. Ha 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 ha. There we go. And so that looks to be it right there. Yeah, so it should be... but why is it +2 and not +1? You could do +1. You could run it with +1 right here for lag. And then you can get that right there. And that's the answer right here. So we haven't made the leaps function yet, but we've got a for loop going right here. And from here, we can turn this into a function like that. Turning this into a function will be very, very quick from here. Does it make sense that I already have all the components for a function? I just need to remove out all of this right here, and I can call this like vector x. And there's the for loop with the I. And we already got our container up here. And it's going to make lag equal to something. So we can just drop this right here inside of here. And let's go to code, reindent lines, and put this inside of a return. And I'm going to do one thing. I'm going to remove lag down here. Oh, did it do it? Okay, good. That's a function still. And so I think leaps will work now. It looks like it's working. And should return that. And then we have messages right here. Should return A and print out your custom message. But is that, Adam, did it start working for you now? Is it now working, Adam? Did you, I think a lot of times people have the error right inside of here. Yeah, this is the part where the error is, because usually there's not a parentheses right here, because this has to evaluate to a number, and then you do the 1 through this number, not 1 through, because if you don't have the parentheses here, you'll make the vector and then subtract 1 from the, you'll subtract from the vector. So this creates the vector, then subtracts from the vector. This right here creates the number that you're going to use for the vector. Does that make sense, Adam? Like, here, this will evaluate this and then do 1 through this number. Without this parentheses right here, it will create, no, without this one right here. There we go. It's gonna, yeah, actually that was right. Without this parentheses here and here, now it creates the vector and subtracts 1 from the vector. Does that, because if you do it this way, it'll do like 1 through this, and then it'll subtract the lag from the vector. Just so you can see that visually. What that does, and I'll show you how the small difference that creates. It's like doing 2 through 6 minus 3 will get you -1 through 4, or -1 through 3, I can't count, or 2 through 6 And then if you do this right here, minus 3, this will then do 2 through 3. Because the small difference down here at the bottom of the screen is what's going on. The difference between the vector 2 through 6 minus 3 is this, and then the vector of 2 through 6 minus 3. So the 6 minus 3 is being evaluated right here, and that's what we're doing right here is we're evaluating this, and that gets evaluated, so it's 1 through whatever number this is, not make the vector, which this makes the vector, and then subtracts 3. Does that make sense there, Adam? And that was your problem, was it? It's a very common thing when I've done this problem, that just the creation of the vector is incorrect, but it's all right. Awesome, great job. And from here, it's just adding custom error messages. And should we figure, is there something that could cause R's knitting process to slow down? Mine's always slow and sometimes doesn't even finish to knit. Yes, do not have, one, send me it if it doesn't knit. I'll get it working, which a lot of people have, and you might have already, I'm trying to remember. But do not have things in like, do not have core demo. Here's things that'll break your knit. Don't have called core demo. Don't have install packages. Trying to think what else. Do not knit this. Do not knit that. Do not knit this. Oh, and also while 2 equals 2. Do not knit this. Why would you not knit this right here? 100 points. Why would you not knit this right here? Why would you not knit this thing right here? Why would you not knit this? Why would that break? Why would that cause problems? I've seen that before. That'll cause, infinite loop. So that'll cause an infinite loop, and it won't knit. Yep. Yeah, oh no. Oh yeah, 1,000 page documents will break it too. So it just didn't finish. Send it to me. Send it to me as soon as possible, and I'll be answering mails, and I'll probably be heading to Kingsport later. But send it to me as soon as possible, and especially doing it now, and then I'll be on the road a little later tonight. So send it to me as soon as possible. What other questions are there? And great job working on it now, because you have to work on these early. That's one thing I reinforce is like, you got to start early on these assignments. Don't start 10 minutes before it's due, or else it won't make sense. And you'll be like, I can't do this. Reply to the email and say, reply to the email, Adam. That'll be the best help to me. And just say, ignore this email, and I'll try to remember. So if you do that, and then we just did 474. We'll do a 320. Anisha, we got yours next. Remind me, Anisha, yours is next. And so 320, and then we're gonna do Ryan's, then Anisha's, then Madeline's. Okay, and then Jordan, yes, send your code, Jordan. Oh, did you already send it? I think you might have. Okay, wait. Okay, let's do it. We're gonna do Ryan's question here, 320 Ryan. Let's do Ryan's question here, and then Anisha's next, because I know you've asked her a few times. You got it. And question 3, exercise 7. Note that you will have to complete this problem. You can print it out. You can save it. This is the email I sent that you can do it any which way. Since you'll be drawing these, okay, so we need to draw. Okay, Ryan, I will do, or Adam, which one was that? I will do 2 of these. I will do 2 of these. Which 2 of these do you want me to do? A, B, C, or D? A, B, C, or D? And I can take pictures of these, which I can then put into my document. I can draw them out here. Which 2 of these do you want me to do? A, B, C, or D? Which 2 of these shall I do? 2 and 3? 2 and 3? Oh, wait, was that? Oh, you meant 2, not 3. Okay. You're like, I got this one, Brian. I got this one. Okay, let's go back up here. Question 2, exercise 6C. Okay, let's go do that. Do what power? Okay. Going over here. Gonna increase font. Got the layout back. Okay, there we go. Question. Let's. My computer is like. This is a supercomputer. It shouldn't have problems. It should do everything perfectly. It is the ultimate computer. Question 2. Wait, what's question 2? There's question 4. Question 2. Question 2. Question 2. Okay. Exercise 6C on 72. Okay, got it. Boop. And we're on page 72. 6C. Okay, here we go. Examine the association between bill and tip amount and what is appropriate using the associate right here. So which measure is appropriate for the measurement of the strength? Is the relationship statistically significant? Does Pyramid... Okay, so we got 3 questions. We need to first create this with the associate. What's the format for associate in the chat? What's the format for associate? And we're using the tips data frame, I think. So examine the relationship between bill and tips using EX2 tips. So here's the data frame up here we're using. What is the format? I need to see the format. Brian doesn't know the format. What is the format? We're doing bill and tips for EX2 tips. What is that format for that code for the most famous associate? What is the format? What is it? What is the format? Yeah, I don't know. We'll come back to that. Yeah, definitely. What is the format for associate function? What is good answers in the chat? What is the format for the associate function? What is the format? I have forgotten it. I have forgotten it. Oh no. This is the rest of office hours. I'll sleep. Very famous format for this class that we should know. I'm going to load up the data set while we're thinking through it. So, yes, Jordan, excellent work right there. Yep. So I'm going to get the data set loaded up. It's the EX2 tips data that loads the data if it's already like a preloaded data. Which variable did it want? It's bill and tip. It doesn't say which goes where. But if you think somebody's tip is probably explained by their bill. So tip, there we go. We'll put it there. Like your bill would explain your tip. Like how large your bill was at the restaurant would explain your tip. That makes more sense. And hopefully I spelled everything correctly. And bill not found. Is it? Oh, it's lowercase bill. Really? And tip. Or they're going to be spelled completely different. And they are spelled bill in USD, and was it tip or tip percentage? I think it's just tip. Tip in USD. So it's bill in USD and tip in USD. So if you really want to spell them, you could go down here and do the following. Well, you can do this. You can go to EX2 tips, and you can see them right there. Bill underscore in USD. So we have to go here to tip underscore in USD underscore right there. And we can go here and go bill underscore in USD, US dollars right there. And we're going to zoom out one time because we're going to make a plot right here and we want it a little bit nicer. And then we run this and we got it. So what do? We go over here. Not to there. We go over to here. Are they both quantitative? Yes. Ours, is it monotonic? Is this here monotonic? Is that monotonic? Is it monotonic? Is that a monotonic relationship between bill and tip? I do not know. Yep, it's monotonic. It means it goes in one direction, so it constantly goes up. Monotonic means it goes in one direction. Non-monotonic would be something that goes like... So here's a non-monotonic. This is a non-monotonic relationship because it goes up, then down, then up again, then down again. Here's a monotonic relationship because at all points it's going down. So this one right here, this second one is monotonic. This one's also monotonic because it always goes up. Now if it's a line, it'll be monotonic. So if you notice how it goes in one direction, but a parabola is not monotonic. So the parabola goes in two directions. So you can look right here if we do like, these are not monotonic. And so this would be like a really quick, like, put a check next to the monotonic relationships. And those are monotonic. So the ones with the checks are monotonic. They go in one direction. It doesn't matter if it goes up or down. Monotonic just means goes in one direction. Favorite band, don't forget that, monotonic. And let's go back here. So now that we have this, we can also look at, it's monotonic. Is it linear? Does a line well approximate this data, yes or no? Does a line well approximate this data? Actually, yes. I know. Actually, yes. A line does do well. We can actually see this visually if we switch to a new thing, which we'll be doing very shortly. We'll be doing it on Monday, and it is on the test. If we do this right here, not summary, I'm just turning it into a visual model, and you can see it right here. So this is the same plot, but with a line through it. So you can actually see that a line goes through the middle of the data, which this is the mean of y. Like it's trying to approximate the mean of y. No, Ryan, don't worry. 100 points, Ryan, and Alexa, and Jordan, and Yaoji. So don't worry if you get it wrong. Then you'll remember. We get things wrong, and they're like, oh, that's right. It's a line well approximates it. We've even got other checks to see if it has a higher order. So I don't know about that. Well, apparently it does. Well, Ryan, you might have been right. because apparently this has some sort of fourth order relationship. Apparently it has some sort of non-linear at the end, right? I'm not joking. Maybe you were seeing this because apparently it looks to be it's picking up on some non-linearity at the end of it. So Ryan, you're at 300 points. You broke the trend and you saw something we didn't see. I'm not even joking because when I run the higher functions on it, we come back with a nonlinear trend and the data points to a fourth order relationship with the R squared adjusted and the AKK information criteria. So great job. You never know. Yeah, you say, well, wait a minute. And I didn't think we printed. No, I'm cool with that. You made me want to investigate it. And this is what we do with data. We just investigate and we see what's going on. So we can pretend we didn't see this. This didn't occur. Boop. So even if that doesn't occur, and these are all the same plots, but with like a line through it or a multivariate or like a polynomial relationship, these are polynomial models. So with this scatter plot right here, do we see outliers? Yes or no? Do we see outliers? It's more this. These are that one and that one, because this is going to come up in the next topic. Like I wouldn't call this an outlier. I'd call these outliers. This is a symptom of something else. I'm saying these points here are not outliers. Really, like, that's not an outlier. That's not an outlier. These are probably due to the what nature of the relationship. Like these are outliers. I'm thinking this is due to the what of the nature of the data. This pattern I'm trying to show you with like, or it keeps getting wider. That's due to the what nature of the data. What do we think that's due to? The whatness. It's my favorite word. It's not the first one. It's not the this. It's the this. Heteroscedasticity. Man, nice job spelling it out right. Did you Google it or did you spell it? Still awesome, because I don't know how to spell it. Heteroscedastic relationship of the data, which means it has a differing strength. And with everything you just said right there, Ryan, were you asking about this? Oh, you were asking about this. You got this. Look at this. It's like people will look in the chat and be like, Ryan's got this. Because what do you think best describes it? Now that we said it's heteroscedastic, it's not homoscedastic. We didn't say yes. It's heteroscedastic. It has outliers. I mean, it's kind of linear, but where do you, Spearman. Yeah. And then how do we decide this? And then we decide based on this, it had outliers and had a strong heteroscedastic nature. So this literally, I thought this flowchart, and I wanted to make this because I was like, I can keep saying it, but if I visualize it, it'll really help students. Like, I hope this helps everybody follow the pattern to be like, this is how you get to Pearson. And it's not like if you have a tiny problem, you go straight to Spearman. It's like, what degree is the problem? Like, you have to be like, well, how bad is this? How bad are the outliers? If it's like one outlier, you're like, if there's a huge outlier, you're like, it's a huge outlier. But you have to look at it at a degree of scale. You can't just say like, if it's very bent, then it's Spearman. You just have to look at degree of scale. And then does it really matter what we decide right here? The answer is no. The reason is, and you can see the answer down below, here's the p-values. What do you think the p-values are for either of these? Here, I'll disappear again. Why is it pausing? Here's one of the p-values, and that's still this p-value. That's part of it, and that's the other half of the p-value. Here's this p-value. Yeah, they're both 0. And we can confirm this really easily by running the code and just looking at the p-values. We don't have to guess it via the picture, but it's so obvious when you go here and you can see the p-values are 0. And they're also both virtually identical. You wouldn't say, oh, it doesn't matter because they're identical, but it's, we've got some problems, and the Spearman's a little bit higher. Like, you don't pick Spearman because it's higher. You pick it because the data points show a Spearman type relationship, which is heteroscedastic outliers. We don't have the nonlinear nature. It's got everything but nonlinearity. But you could, see, the fourth order has this dip, but I still don't see it. It was magic how that occurred. There's the apparent, but that's, it's kind of still monotonic. It still kind of goes like this, so that fourth order, and that's probably why the Spearman's a tiny bit higher. For the most part, the linear does a good job. The red line you can see in the middle, but then the fourth order has a slightly, it's probably why the Spearman's just a little bit higher than the Pearson. It's picking up on the and it's downweighting outliers. It'll downweight outliers because outliers can't have a huge impact because they're all ranks. So nothing can be an extreme outlier. And then right here we have that we are confident. So the choice doesn't really matter. So hopefully that helped out a lot with that question. Do you feel like you got that one really good, Ryan? Doing really well on that one? Know what's going on? And then I think, what was it? Oh, we're doing Anisha's question next. Anisha, we got you right here. Anisha's question was 5B on 474. 5B 474. Let's take a look at it. Ah, cool. I love the card one right here. So the way I've already kind of started this one here a little bit, and if you look, I've created some cards right here. So we're gonna do simulating card values right here. Let's hop back to the chat. So have you already created? If you don't have these, Anisha, then here's the cards in the chat for you. Just copy and then change it around. So what we want to do next, and let me explain the point of this problem for anyone watching this, is in Vegas, you don't, okay, cool, there's that, and here, you got that, cool, you have it, cool, awesome. So that assigned low values, medium, high, and high 2. You could just put these together, but still, it doesn't matter. Okay, so what we have right here is when you're counting cards in Vegas, the deck is either going to be hot or cold. And what do we mean by that? When cards go on the table, they go out of play because they're going to wait to shuffle the deck. So when they shuffle the deck, it'll reorder them, and you could say the deck value is at 0 again. And the deck will be hot when there's a bunch of good cards in there for you. The deck will be cold when there's a bunch of bad cards. So you might say, well, why, like you would think Jack, Queen, King, Ace are good cards. Well, why do they get negative values? Because these cards right here in the high are going to get removed. If they get played, then we can't get those cards. So when would the deck, the cards be really good? It'd be if all of the cards that have gone to the table are like 2, 3, 4, 5, and then 7, 8, 9. I mean, 7, 8, 9 are neutral kind of cards. But it'd be good if we saw a bunch of 2s and 3s go out in recent hands and they haven't shuffled, because that would mean there's more 10, Jack, Queen, King, Aces in the deck. And if you get like Queen, Queen, well, you've got 20, and you would just say, I'm not playing, because you can only get an Ace to improve your hand. So if you got Queen, Queen, if you got that every hand, you would be probably winning a ton of money in blackjack. It's probably a very good starter. You could split them. And then hopefully if you get an Ace. So some places allow that. You say, I'm splitting my queens. And yeah. Hey everyone, no rush at all, but the Tyler Evergreen website doesn't allow me to copy the address for the image. I could just copy yep, Brennan, 100 points right there. Thank you for asking, Brennan. Just copy it. Maybe they changed it. But if you can't get that to copy, just copy paste the image. Great question right there. So what do we have right here? Never split queens. There you go. 100 points in right there. So that's coming from a mathematician right there. So take that advice. Don't split queens. Don't split queens. Split aces, right? Definitely split aces, because you'd only have 12 or 2 with aces. And then if you split it, always split it. Yeah, you'd always split aces, because all you have to get is like King, Jack, Queen, King. And so you're probably one of your splits is probably likely, especially if the deck's really hot and you get 2 aces, always split that. But then we talked about counting last time. So if you look at right here, what we have right here is we're going to pick a card, any card. And then we're going to go right here. We're going to put a multiple. And we're going to first assign to value if the card is contained in these low cards. Here's the low cards. Well, I don't have low cards. Now I have low cards. So if the card is contained in these low cards, then we will assign the value of 1. Now it's a 5, so we've actually just assigned the value of it. The value is going to be, whoops. Oh, did I not create value? Oops. Well, there you go. Value... concatenate. And so we go here, and the value's null, because it's 5. Oh, it's a king. Ha ha. Ha 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 ha. So it's not been assigned yet. I saw the multiple. Now it gets assigned here, and you just saw it appear. So now this is the current value. And probably the easiest thing we can do right here is we could turn this into a function really quickly. To turn this into a function, all we're going to input is the card. And so I'm going to remove out this card part of it. And then all someone has to do is they're going to take this, they're going to go here with function, and they're going to put this inside of it. We're going to re-indent our codes. Code, re-indent lines, and then we're going to go right here. Values shouldn't be here. That's going to overwrite values each time. Oh, no, I guess we could do that. And then, so we'll see if that messes it up. And then Ben, I guess you're next right here. Then we're going to go right here. Someone's going to put a card. And what is this supposed to be called? what's the function supposed to be called? It's supposed to call like evaluate card value. There it is right there. And we're just going to copy that. We're going to go here. We're going to run our function, but we need to put around here. What do I need? I want my function to end with this. I want my function to do this last. On Q4A, on the BAS 474, do we use the image that's already in the R chunk? Or are we supposed to go to copy paste a new one from Tyler Vegan? New one, Ben. Return, great job. Ahmed right there. And we go to return, and we run this, and we go to card value, and we go to queen, and it's got ooh. Da. That's why you check your code. We don't want that there. We want this there. Now we do it. Okay. That's why you check your code. Because I had already hard coded in a multiple. So you don't want to hard code in your multiple because you want a user to pick it. And we're going to define, I think, the multiple to be 1 by default. Yep, copy paste in the specific one. You got it. Is this looking a lot better initial right here? And then you just for loop it over the vector of cards. So you'll just have it evaluate and store. And just be careful, get it to work on one card and then have it. And then there's error messages and stuff. I don't think there's error message on this one. Does that make sense? And great job. I know like for the 522 students, I'm really impressed. The 522 students, I think some of you are PhDs, some of you are MBAs, but the 522 students I'm shocked. I've looked. Are you an MBA or PhD? But I've been really impressed. How do you indent? Highlight your code and then go to code, reindent lines. Highlight your code and go to code reindent. Dr. Petrie taught me that last semester. You are a PhD, or you're a PhD candidate, or you're a PhD now? What are you doing your PhD in? And congratulations. I did a PhD for 2 semesters and it about killed me. I was like, I can't take it. Can't do it. Kind of serious about that. Teaching in PhD was a lot. So I have the utmost respect, PhD candidate. Well, congratulations. It's all right. I love what I do. And 3rd year, congratulations. That's, yeah. And PhDs are, I have the utmost respect for people who earn PhDs because I've done it. I mean, I've tried it. I've attempted it. They were letting me do the program and I just told them I can't teach and PhD because number one, I'm never going to let my students down. I'm not going to be like, oh, I don't have time to get this ready, or oh, I'm tired, because I would always put my PhD studies second, and I was staying up most nights till like 3 a.m., getting up at like 7, 8 a.m. So I was going like, this is probably what it's like for you guys anyways, but I was, going 10, 15 days with like 4 hours of sleep on average, or 5 hours of sleep. It was like 4 or 5 hours of sleep for 2 or 3 weeks. And then I was just like losing it. I was just like, I'm tired. My brain's not working 100%. So I felt, yeah. Well, thank you, Ben. That's why I was like, I can't teach and do a PhD. So yeah, but no, you guys come first. Like, you guys get all my energy. Well, I mean, you get all my teaching energy, you get all my job energy, all the what I'm paid to do. So I'm just kidding. I was making jokes. So which part are we stuck on? Which question do people have? Feel free to say, Brian, go back to this question, or, oh, thank you so much. I love it. Dr. Brian, I'll take your knowledge energy. No, you guys really make it, because we're just talking for a half second here. And then tell me another question if you want me to do another question here. But it's just practice. And that's why I like working these problems with everyone. And I know a lot of people take advantage of this. Like, I know, and we have a lot of people watching live, which matters. We have people who can't watch live. You're welcome. No, this is what I do. And this is my first summer session teaching 2 classes. And I will say this has been, it's been, because I'm doing 2 classes. So I'm making sure everything for 320 and 474 is on track. And then I want to give like as much attention as I can to both classes. So this has been one of the busiest summer sessions I've ever had. Have you decided on a date for the coding exam for 320? I think we'll do Thursday. I'm keeping structured. It helps my brain that 320 and 474 I'm using the same days for. So I'm using 320s and 474's midterm is on Tuesday, and 320s and 474's final is on, coding is on Thursday. And then a lot of times 474 has had their homework due before 320, like the day before. So that way, when we do office hours, people can come in for like 320 office hours and that way, but I think tonight you both have one too. It's just like, oof, summer's so quick, but I'm really proud of everyone. You know, I've seen so many people working so hard, and I love the positive attitudes. Have you gone over any? Yep. No, feel free to ask, Ben. It's in the video, but I can answer it too. We can feel free to ask. Like, feel free to ask. You can ask anything. I'm probably gonna stay for another 15, 20, or like, I mean, as long as people are asking questions. If we, oh, Ryan, you're awesome, man. Throw some timestamps on the video at the end, so I might end the video soon here. Oh, so once the video ends, have I done 5A for 320? Let's find out. Let's look. Let's do it. 5A. Where? Yep. Well, we can do it again. Let's do it again. Let's do it again right here. Okay, so core demo. We talked about this. I sent you an email on 7, by the way. Awesome. FPR5. What does that mean? I don't know what that means. Where's core demo at? Okay, so the thing about core demo, and I mentioned this at the start. So core demo, you have to run it down here especially, and it'll run. If you try to run in a chunk, it'll often have problems. That's the quickest explanation I can give is run core demo down here. Another thing you should know when you're finished with core demo, hit finish. That's key. When you run core demo, then when you want to finish it, boom, right here. So this one says we want to create a plot, generate a scatter plot, which has a correlation of this. Once this has been done, click the export button, and we just want this right here. Now, don't worry about exporting it. You can just drop it in your assignment afterwards. So we go right here, and we start drawing pictures. We make it look nicer. Cool, that looks nicer. And it wants it in the top right corner, and we're doing pretty well. I think we've outdone it. And it wants it top right corner. It said, if you notice, if you put a point out here, this is going to make it weaker. If you point inside of here, it'll make it stronger. Look at, oh, it didn't make it stronger? Oops, I was wrong. It said 0.8, right? Where is my correlation at? Is it over here? What is going on? I've lost my mind. There we go. It said negative 0.8. So this has it right here. I want them both to be negative 0.8. There we go. Got them both to be negative 0.8. And so what I would do right now, you're welcome, Anisha. Thank you so much. You guys, like, once again, I love the positive attitude of my students, and I love how much you guys are helping each other out. I'm going to take this, bring it over to a Word doc, copy, paste, and that's my image. That's my image right there. Does that make sense right there? And you send me an email about it. I'll probably take a look at that pretty soon here because I'll probably start answering emails. So, and are there any other additional questions? There might be some more like 320 or 474 I missed, but that I kind of went overboard here, but that's a negative 0.8 correlation right there. That's a correlation of negative 0.8. So that's got that. Yeah, no, once you see it, you're like, oh, you just want a negative correlation of negative 0.8? Yeah, cool. And then got it. And I've done these problems a lot. Like, these are book problems, so we don't really change them, or I mean, they're ones that we've kept the same. We're going to start, Dr. Lou and I are going to work, or young Lou and I are going to work on updating assignments during second session of summer because I don't usually have a lot of time. You're welcome, Jordan. Thank you so much for showing up. I really appreciate it. I opened core demo and didn't add anything because I was watching along. Then when I had finished, wait, Snowden. I should watch Snowden. Edward Snowden. I should check that out. I think, is that recent? I should see Snowden. Tell you guys what I think of it. Tell you guys what I think of all these new movies. I really want to see Joker, though. Like, as soon as Chelsea and I have a day off together, I'm going to be like, let's watch Joker. Yeah, I wonder, does he talk much about coding in it? And Ryan, if you want to send me the error message you're getting there, send me the error message. And what error, like, send me the error in the chat. I bet Snowden codes in C++ or C#, or error in head object ex2 census not found. You must have, like, put that in. It's all about coding? The whole movie? Oh, now I really want to see it. See what he's doing. I wonder, like, how true it is. Hopefully they like it's like real coding. It's not like I'm gonna hack the matrix. Like, whenever I watch people like type on keyboards, they just type like they're just like this. You're like, you're not coding. It's like you could type faster and still be typing something. Oh, no. Oh, thank you, Word. That is still words. Let's see how fast I can type. You know what we should do? There we go. You want to see how fast we can type? Let's see here. How fast can I type? This is going on record right here, Dr. Petrie. So, online speed typing test. There's ones for this. Free online typing speed test. Okay. Let's go to whatever. I don't know about these sites. Typing test. Complete a typing test in 60 seconds. It's all these like random things. Start a typing test. Okay, so I'm going to do this right here. So this is real deal. I'm going to take a picture of it when it's done. So I'm going to take 1 minute right here. I'm going to type this typing test. I'm going to take a picture for you guys when it's done. So here's the typing test I'm typing. I'm going to totally fail this. So let's take the test. We're going to do this test over here. Like I'm clicking inside the box. I'm going to totally fail this. I'm going to get like 60 words per minute to be said. The tiger panthera, oh my gosh, tigris, one of the world's most magnificent and revered animals, faces possible extinction in the wild. Since the turn of the century, its habitat and numbers have been reduced by 95%. For 1 million years, the king, don't change my thing there. King, I just messed up. The jungle lorded over a territory stretching from eastern Turkey to the Russian Far East. Its forest home extending northward to Siberia and up. 77, mistyped words 3, typing speed 75. Well, that's a bummer. Well, that's good. Man. Oh, I got to fast but not pro. That's a bummer. Well, there we go. There's my results. I had a little fun there in the background. Click insert in the NAR. Oh, yeah. Sorry, guys. I was having fun in the background. Typingtest.com. I think that's what I just used. It's got ads, so I didn't show the ads in the background. Yeah, I just used typing test. And then it says, improve your words per minute. That's just so weird. Like, does it let you just do a random, like, type your own words? So, typing test. 3 minutes has sentences, words. You can do words. Oh, man. See, okay, wait. I think we'll be good. Whatever people saying in the chat. You should do coding speed runs. Let's see here. Click insert, and then I think everyone's helped out. Look for an insert at the top of our. Click it, inserts. You guys are awesome. Thank you so much. Jordan and Sylvia, 100 points each. Okay, let's do one last coding speedrun thing right here. You ready? Okay, I'm going to try one last time right here. I'm doing it off screen. Citizen. Oh my gosh. It's hard because I have to turn my head. That's what I'm going to blame this on. Okay, so here we go. This is my last thing for the... Oh no, I just broke my streak. No. Oh, I literally... 83. The second to last word was brain. So it was 83, but then the real word, because I had to I think if you do errors, you get delete. And at one point I was at 90 at the start of that. So bummer. Well, never going to hit that 100. Never going to hit that 100 words per minute. One of these days. So there we go right there. So I'm getting up towards 80, but it's, I don't know. How are we doing? Okay, let's get serious here. That's my fun for the day. Error in new point. Argument is of length 0. I'm around 64. Nice job. That's good. Yeah, no, and I just want to get faster. So getting 79, I got 83, but then because of my errors, but then I thought I corrected them. It's hard to see because I'm turning my head. I can't look at it down here. I'll keep trying. I want to get that pro range. Sylvia, you're getting. Can you send me a picture of the error, Sylvia? Argument. It's in the plot thing, is it? It's Sylvia. Wait, I think I know the error. Sylvia, are you? I'll get serious here. Sylvia, are you doing the plot down here? Oh, look. I'm getting the same error, but you need to run. Oh wait, go right here. And am I still running it? I'm still running it. So it looks to be running. I think I might just give that error now. So I think you get the error when you finish it. So Sylvia, are you able to make the points like this? How are you doing on this, Sylvia? I'm getting serious here. Sorry, I was just having some fun for a second. Are you able to make the points right here on this? Is this working for you right now, Sylvia? Are you able to do like this? And then you end it, and it does that. So I'm no longer getting that error right there. Might be due to size of window, but how's it looking? Let's see. You can't even get, are you running the plot down here in the bottom? So do you see where I'm at in the bottom right here? Run the plot down here in the very, very bottom. So are you running it down here? And then have your window big enough. Make sure your window's big enough. So have your window big enough, like increase the size of the window. Yeah, there you go. Sylvia, great job. 50 points again, Sylvia. Don't worry, people were emailing me about that, and it's just, I forget that that's a problem if you try to run it in the top. And if you run the console, it works. You're welcome, Sylvia. Sorry, I was playing around doing word typing games. And after I saved image and try to run this code, it gives an error. Yeah, don't even worry about, oh, so these codes are not codes. You remove the arrows around them, and so these go to your computer and grab the file in that location. The file needs to be in your working folder, but Ben, to get around that, just insert it afterwards. It's the easiest way. I mean, you can save the file names as is, and then it'll knit those into the file. So this is the name of what you're going to call it, so it doesn't matter what that's called. This is the name of the file in your files. So if you put this into your working directory, it'll pull this file name and it'll insert this image right here. So that's how you insert an image. See, it says no image path with this. So it's saying it can't insert this image into my thing right there. So it's saying there is no image of that. Does that make sense right there, Ben? That it's saying there is no file thing right here. There is no file thing. But if you want, just knit your file and then just like take a picture of it. So take your picture, like if this is my picture, whatever I want. Take your picture, and once you take the picture, insert that into Word afterwards. So go to Word and just insert the picture. Yeah, just do it once you knit and then but don't forget to put the pictures. People do that sometimes. So that's probably the quickest, that's the easiest way. This is my error value matrix half window out of bounds. So that looks to be that your plus or minuses. Jordan, send me your full RMD. Here, I'll hop off here in literally a moment. Jordan, I'll respond to your email first. So send me your RMD along with the screenshot of that message. And, oh yeah, let's do question 3. You got it. Vedrina, let's do it. I got an error. I'll play some Mega Man. Let's do question 3, 474. Let's do it. And then Jordan, once I jump off here, I'll do your question. It's like my hype music. All right, here we go. Okay. So this is the Spanish one right here. See you, Ben. Good seeing you, Ben. So this right here is the Spanish stuff. I'm just removing some of our work so we can talk about this more from the start. So write a function called Spanish that takes 3 arguments, x, n, and then na remove equals false. So this is going to be the default for the function. The na remove is true. Any nas should be removed from the vector. So it gives us the function right here to remove those. So what does Spanish do? Spanish is going to take a vector, such as like this vector right here. Let's just take this vector. And you see we get checks for it and everything, so that's good. So Spanish is going to take a vector x, and when we store into x, and I hate how that's written out, it's because it's in a function. I hate that. I don't like it. It's going to take it, and it's going to remove out certain things on the sides. This says n equals to 2. So let's go ahead and grab that right here. Let's go grab the n equals 2. And we're going to do it as not a function, though, and do it that way. Okay. So here's what we're going to do to this. We need to find this vector sorted first. So we're going to sort this vector. Let's go ahead and sort it. Reason being is we need to remove out some of the elements. And if you take a look at what we have right here, when we display x, there's the sorted version of x. And the way Spanish works, the Spanish function works, if you read the top part of it, is we need to take the, we're going to remove out the top two elements and we're going to remove out the bottom two elements. And then we are going to take their distance. Oh, let me double check. Why can't I think? So we're going to take out the second smallest value and the median is this. And then we divide by the median. Okay, we're going to take the range between those values. Oh, you're welcome, Jordan. Glad to help out. Thank you guys for chilling. And then we're going to take the range of these numbers, and then we're going to divide it by the median. So that's the median of the data set. You can see the median here. There's 4 numbers below it. There's 4 numbers above it. And then if you knew we're doing Spanish 2, which is going to use the second largest and the second smallest. Does that make sense that with Spanish 2, we're going to take the second largest and the second smallest? And so we can actually do this pretty easily. I always think of new ways to do this one. Now, when we do this right here, when you look at that vector right there, how can I always find, good job, I like it. How can I always find the second smallest? Like, look at this vector x. There's x. We've now sorted it. How could I find the second smallest? How could I find the second smallest of x? What code could I run to find the second smallest? What code could I do to find the second smallest? What code would get me the second smallest of that vector? Let's just look at the vector, identify where the second smallest is at, and then how would I find that second smallest with code? Like, how could I always find that one right there? Yeah, we could. And actually, you know what? We should be able to do that. So we should be able to do that right there, and that'll find the second smallest. So that does it. That does it. And I was also thinking of, that gives it. So if you notice, these two codes right here are going to find the same thing. Just look at the code and look at the code. But we have to watch out with this. You know, I say this, but you'd have to do this because you got to watch out, because if you do something like this, you might get NA. Yep. But if you do something like this, you won't get NA. So if you put the head function, you have to get at least that many elements. So the reason I'm writing it this way is because guess how we're going to find the largest? Guess how we're going to find the second largest? Do you have a number of points for the... No, as long as it works. Fewer points generally works better. As long as it works, tell me if you think the greater was mean, and I'll give points back. Unless it's like ridiculous, and I'll be like, you can't do it with 1 point. You can't. So there's no way you can get the answer with 1 point. What do you think we can change right here to get the second largest? What could we change like that to get the second largest? Any ideas? There's silence. We could, but it's going to augment. So how could we always get the second largest? So think, it's always going to be, like, this second largest is here, the third largest is here. You could do that, and this is going to cause, so I think you can do that right there. I think Ahmed's got a way of doing it. Watch this, though. Tail, and now the tail, I think we just want the first element always. Reason being is if you report the tail, it's always going to be the numbers in this order. So those might work. Those all might be ways. But what I'm doing right here is I'm working with this vector down here, and I'm making sure I get this. But let's do this, and let's go right here, and let's store into here n. So let's call this n. And then let's run it. Oh, awesome. If you want to reply to that and be like, hey, ignore this. That'll be good. And now let's go to the third. Now what we're going to do is we're going to look at this, and we're going to make sure we get the third, which should be 3 and 9. 3 and 13. Oh, because this is always 1. There we go. That's always 1. So this is why you run your code and you make sure it's working, and you do a test case. This is the test case of it, where if I have this vector that's been sorted, and I want the third smallest, and I want the third largest, here's the third smallest, and here's the third largest. Does this make sense what's going on right here? I could call this smallest, and I could call this largest. And that's got it. Those are the smallest and the largest. And now we just need to go, let's go here, largest minus smallest. And we're going to put this inside of a parentheses right here. And then we're going to divide by the median of x. And that should pretty much do it if we divide by it. That'll be good. There we go. And this is with Spanish 2, but we need to check Spanish 3. We need to check Spanish 2. And that's the answer it says we should get. So this is the answer it's telling us we should get, and we've now written it mostly out. From here, we just need to clean this up and put it into a function like I don't need to print x. I'll no longer need to save 2 into here. And this will have to go inside of an if. So this will have to go inside of an if. And this will be the code that runs. So there'll be an if right here. And that'll be the code that runs with it. And we will not let someone input their x. We'll let that. And that's cleaned up, ready to be functioned. How's that, Vedranel, right there? How is that? Does it make more sense? Are you pretty far into this one now? How's it looking? And from here, and the if is mad at me because I don't have the condition inside of there. It'll be related to the NA remove, and then that'll run a certain thing right there. It'll then run this if NA remove equals, don't go right here. If NA remove, if you could really do just NA remove right here, because NA remove will have stored into it a certain thing. How is that? Is that looking pretty good for everyone? Error in largest minus smallest median non-numeric argument to binary. Do you have in your global environment right now the largest and the smallest? Have you stored largest and have you stored smallest as your test cases? So make sure you have them stored, and then they should run. You might have to send it to me, and then I can take a look. So make sure that you have these stored right here. Make sure that they are created and storing into it. Awesome. Yeah, we'll probably do that here. I think that's got it. Good office hours, everyone. Oh, we totally got this. Send me the email. I'll take a look. I'll figure out what's going on. This is going to be the easiest way for me to do it. I've got Jordan's email and Vedranel's email. So, yeah, there we go. Awesome. Am I getting 100% lately? Am I 100%? I think so. I hope. And that's got it. You're welcome. Thank you guys and gals so much for being here. It's been a good day. We'll see here. I need to load up the other outro. You're welcome, Ryan. You're welcome. You know what? Let me see something. Let me show you guys. You get Jason, we just need to film for another 4 or 5 hours. We've almost got these new intros ready. We're almost there. This has been good. You guys get to see a special outro now. I'm gonna get a haircut between it. Okay, here's our special outro. I'll play it next class, but here's a special outro for you guys. So thank you for being here. Here's a special outro for being here. So Jason, can we continue on? Jason, let's do this. Jason. 5 hours. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.